Hopefully this one's a bit nicer than the other one. Special offer. Buy one, get one half price. So that means 2 books. Let's find out the cost of 2 books. If you buy one and get one half price, that obviously means you're getting 2 books. Well, the first one is at the full cost of £10. Add the cost of the other one at half price. So we add the £5. So we know 2 of these books would be £15. So if 2 books equals £15, use this special offer to work out the total cost of 12 books. Or what do you times 2 by to get to 12? 6. So 6 more lots of these 2 books, which is 6 lots of £15. 6 times 15. Remember, if you've got a calculator, use it. Your answer is £90. Again, slightly different ways of doing it, but £90 will give you the right answer. Okay, for this one, it's quite a nice question. 90 degrees clockwise to open a lock, 180 degrees anti-clockwise. So, let's have a little look. My advice would be, choose a number and stick with it. Well, I'm going to start with the number 0. And we know, to open a lock, turn it 90 degrees clockwise. Hopefully you know 90 degrees is 1/4 of a circle. So, after I've turned it once, 0 will now end up here. But then it says 180 degrees. Well, 180 degrees is half of a circle. Anti-clockwise. So because it's anti-clockwise, we know it's going to go back the other way. So here is my 0 now. And we need to go back 180. Well, here is the first 90. There's the second 90, 180. So 0 now ends up here. Well, if 0 now ends up here, let's turn it so 0 is facing that way. What is now going to be at the top of the dial? It'd have to be the number 10. Quite a nice question. Okay, for this question, it says a computer works out the number of blocks for a wall that is 4 feet high. Well, as you can see here, the 4 is the same in all of these examples. So if the 4 is the same in all of these examples, there's got to be a relationship between these. So I'm going to start to find out if there's a relationship between 36 and 8, 54 and 12, 31.5 and 7. Well, it's not going to be adding on the same number because clearly 12 add something would be different to whatever you add to 8 to get you to 36. Same with 7 to 35. So I know adding and subtracting is not going to work, which leaves me with multiplying and dividing. So what I'm going to do is I'm going to try dividing the number of blocks by the length. So, number divided by the length. I'm just going to try it. So I've used a little bit of common sense, but I can understand if you wouldn't know where to start. 54 divided by 12 for the first one then. Let's try that. So 54 divided by 12 is going to give me the answer of 4.5. That's for the first example. Well, let's try it with the next one. So if I go to the one on the right, 36 divided by 8, and we know the other one's going to be 31.5 divided by 7. If 4.5 is given, we know that's, for both, we know that's definitely some sort of link we can use. 4.5 again, lovely, so we're in for a winner. And we'll try it again, 31.5 divided by 7. Once again, 4.5, winner. So we know the relationship is the win. It is 4.5, not the winner. So the computer uses a rule. What is a rule? Well, we still haven't answered it yet. So let's write down here what the rule is. Well, the rule is always going to be if the number of blocks divided by the length is 4.5, to find out the number of blocks, it would simply be the length of the wall. So it's the reverse of it now. The length of the wall times by our number in common, which was 4.5. And that will always give you the number of blocks needed. Okay, bit of a tricky question to finish on. I lie. Not to finish on, one more to go. How many solid gold paving stones could you buy with £100 million? Well, 100 million would look like this. Just so you're aware. It says, assume a paving stone is 90 centimetres, 60 centimetres by 5 centimetres. Well, if I just sketch that for you, that is because it is actually a cuboid. So 5 centimeters deep, well, effectively, it doesn't matter which way you write it, but 60 centimeters, 90 centimeters, 5 centimeters, effectively they are your 3 lengths. 1 centimeter cubed of gold weighs 19.3. Gold costs £33 for every gram. So it's this bit we need to get our heads around. Okay? We want to know how many solid gold paving stones can we buy with this. Well, the only way we can find out how many we can buy is if we know how much it's going to cost. And the only way we can find out how much it's going to cost is by finding out how many grams are in. Find out how many grams are in a paving stone. And unfortunately, the only way we can do that is by finding out how many centimeters cubed are in it. So centimeters cubed, the giveaway there, that cubed should be, hoping you think, let's find the volume. So let's start by finding the volume of this shape. Well, to find the volume of a cuboid, we multiply the 3 lengths together. So it's 90 times 60 times 5. Times 5. So start by doing that. 90 times 60 times 5 is 27,000. So 27,000 cubed would be what's needed for 1 paving stone. But what we do know is for every one of these centimeters cubed, so we got 27,000 of them, it's 19.3 grams. So we now need to multiply the 27,000 centimeters cubed by 19.3 to find out how many grams are in one. So we're going to have a really big number. 19.3 times by 27,000. It's going to give me this not very nice number. 521100. So it's 521,100 centimeters. Sorry, not centimeters. That would be grams. So this is how much is still in one. We're always looking at one still. But now what we do know is with this number, it is 33 pounds per gram. We've got all these grams. That means per gram, which means for 1 gram. So we now need to do 33 pounds times by the amount of grams in one, which is 521,100 grams, 521,500. I've already got it in my calculator, so I'm just going to click times 33. Again, really, really large number. 171,96300. Okay. So what we do know now is this is 17 million, so I've put just commas every 3, 17,196,300. This is how much 1 stone costs. But we had a lot more than 17 million. Luckily for us, we had 100 million. So to find out how many I can buy, it's going to be 100 million divided by the cost of one, which is 17,196,300. Again, I've already got this in my calculator, so what I'm going to do is just put my fraction button there, or you could write divide instead. I'm going to write 100 million, so that's 100, all those zeros, and I'm going to click answer, so it's already there, I don't have to type it out again, and I've got the answer of 5.81, 5, etc. Well, we can't round this up because we wouldn't have enough money, so how many paving stones can we buy? Unfortunately for us, we can only buy 5 of them. Okay, for this question, we're just going to have a look at how did they calculate the 18%? Well, to find the 18%, it would have been the games won, 32, divided by 177 times by 100. So if I type that in my calculator, and I'll also rewrite it down here, 32 divided by 177, and then I'm going to click times by 100, gives me the answer of 18.0. So 18.0 would round. 18.07 rounds to 18%. So if we now do the same for the next one, the only difference is she's still won 32, but she's played one game more. 32 divided by 178 times by 100. So 32 divided by 178 times my answer by 100 gives me an answer of 17.97, etc. Well, again, if we round that, 17.9 would bump up to 18%. So, explain why the percentage still shows 17. Well, because it rounds, sorry, it still shows 18 because it rounds to 18%. Providing you understand the first part, the next part is pretty much the same. Is when's it going to drop to 17%? Well, she can only ever win 32, but the thing which changes every time is the amount of games she played. We know when she played 178, it was still 18%. So I'm going to just bump it up to 180 and find out if that would round to 17. So let's try that. So using my calculator, I'll do 32 divided by 180 times 100. Okay, 17.7 recurring percent, so that's a no, because that would still round to 18. So now let's change it to 32 of 181. So we're getting quite close. So I'm going to change just to one game. This is why hopefully you can be pretty good with scientific calculators. It does make life a little bit easier. 17.67. Alright, we're still not very close there, are we? So let's go down to 32 and I'm going to jump to 183 now, just to try and speed things up a bit. 183 games, we'll go to 17.48, so that would round to 17%. However, I just want to double check because I missed out 182, so I'm just going to double check that too. So I'm going to make a little note saying check, which would be 32 divided by 182 times 100. So 32 divided by 182 times 100 gives me an answer of 17.58. So no, that wouldn't have worked. So this is our right answer of 183 games. So it says show calculations to explain your answer. We've already done that. Question said, if Megan continues, when will the computer first show 17%? Well, it will be after how many games? 183 games.